To find the domain, range, and asymptote of a log, I first need to know what the basic log function looks like. The basic log has an asymptote on the y-axis, goes through the point 1, 0, and goes upward to the right. Now the only way that I can change that asymptote is by moving it side to side, which is going to be a horizontal translation. To find out what the horizontal translation is, all I do is take whatever is inside of the log and set it equal to 0. And then I move over everything to the other side and solve for x. So I get x is -5. That's the equation of the asymptote. Okay, and the domain is actually the same as the asymptote. It's either bigger or smaller than -5. Usually it's bigger than -5, but because of this negative sign here, this is a reflection over the y-axis. So actually my basic graph is going this way. So it should be x is less than -5. So watch out for those negative signs. The range is whatever y can be. You'll notice that y goes all the way down to -infinity and all the way up to +infinity. And this is always the range for a log function. To find the domain and range of an exponential function, we've got to realize that the exponential is the inverse of the log. So instead of having a y-axis asymptote, it has an x-axis asymptote. Instead of going through the point 1, 0, it goes through the point 0, 1. So the only way that we could change the position of the asymptote is by moving the graph up and down, which is done by the vertical translation. So the asymptote is 11, and the range is bigger than the asymptote, unless there's a reflection. So watch out, just in case there's a reflection, then it would be less than the asymptote, but if there's no reflection, if it's positive, then we're bigger than the asymptote. And the domain is all the possible values for x. The domain of the exponential function is always -infinity to infinity. Now to check your work on this, you could graph it. So for the first one, we would just graph 16 log -3x minus 15 plus 7. When we take a look at the graph, it's kind of hard to tell that that's a logarithm graph. So sometimes I need to zoom out or change my window. Looks like I need some more y values here to be able to see it properly. There, that looks more like it. Okay, so there's actually an asymptote here. It keeps going downwards even though it doesn't look like it in the picture. If we take a look at the table of values, we can see that most of the values are in error. I think we need some negative numbers here. As soon as we get past -5, then we start getting values. So -5 is where the asymptote is, because that's where the last error is. And the graph is all the numbers less than -5. So if you want to check your exponential, we can also type in the exponential graph. Always make sure that you've got brackets around the whole exponent. I'm going to go back to a standard view, and let's see. So because my asymptote is at 11, this graph only goes up to 10. I can't even see the graph. So I'm going to double my y values so I can see the picture. There's the asymptote, and then the graph should hopefully go upwards. Yeah, that looks like an exponential. So I can see that the asymptote is at 11. If I trace along, you can see I'm pretty much at 11. And then the graph goes upwards. So your graphing calculator can help you check your answer.